We'll begin in a couple more minutes. I think we're going to get started. Good morning, everyone, and thank you for joining us today. My name is Kelly Timko, and I'm with the Business Development Department at Galarath. In order to be sure we stay on our schedule, we're going to begin, and all lines have been placed on mute to avoid any background noise. However, if you have questions or you need any help, you can use the chat function to speak with me. And we will have time for a question and answer session at the conclusion of the presentation. And this webinar is being recorded, and it will be available for additional viewing on our website. It's our pleasure to have Joe Falqui, Product Director, and Dr. Chris Rush, Product Lead at Galarath Incorporated with us. And they will be taking us through today's webinar, Streamline Your Sheet Metal Cost Estimates Directly within CATIA V5. Sheet Metal Cost Estimator interface provides a way to simplify the creation of sheet metal cost estimates directly from within CATIA. And today we see the sheet metal cost modeling capabilities within for manufacturing. And those will include operations for preforming, forming, after forming, detailed part finishing, and some others as well. They're also going to show a demonstration of how that functions in CATIA. So go ahead and turn the presentation over to Joe.
Good morning, Joe Falqui, Product Director for Hardware Solutions. And what I'm going to do between Christopher and myself is I'm going to show you some slides, and then I'm going to switch over to Chris, and Chris is going to give you a demo, as Kelly said, of the model, working with CATIA 5. What I have to do first is give you an overview of both our fabrication model and the Aero sheet metal model will be used and can be utilized in CATIA 5 to develop any estimates that you might have. We do have conventional machines and all kinds of cutting and forming operations. The fabrication model, we're cutting from gas flame, laser, notching, etc., forming processes, as well as bend, plate, roll bending, etc., so that you have a full operation. Any of these operations are usable within the tool. With a shape, and that will get up from CATIA automatically, put in length and the width, etc., the thickness of the material, all of that can be picked up from the CATIA, and that will be read into our model. You can use do forming operations and finish operations based on templates that we've built off by a forming operation or a type of part. So machines, CNC turret press, bolt and rubber presses are available, as well as joggle, hot and cold, plasma arc, and gas flame cutting are all available to the user. Jet is another option for cutting. If you have high quantity, dedicated tools and dies are progressive die forming. Drop hammer, both traditional and hydroform type forming with rubber, stretch forming, tube bending, plate roll bending, all are available in the basic model for fabrication. Routing, check. That metal portion to areas type parts and sectioned off the same way with pre-form, form, after form, and finish. And typically we'll use parts 250 thickness and down. Anything over typically is a machine part, right? The thing to remember about the sheet metal model, the sheet metal model, is that it was based on over 500,000 parts. What we did an analysis based on material forming processes and segregated all that data of over 1 million parts into by forming, after form, finish operations, so that they are the driving force to give you an estimate. So what we do is select the forming process, or in case in CATIA, type of part. You can make up templates for types of parts that take certain forming and after forming operations and get valid estimates by read data from CATIA, the material type, thickness, and the area, the length and width, and will automatically produce an estimate based on the quantity presented by the user. And like the length, the width, and the area will be popped in from CATIA within a manual entry, as well as the part thickness. The material type, and associated to that, to give you the material cost, which may be the largest driver in a sheet metal part, depending on the type of material. And then, as far as preforming operations, the material the operations are available. And these being available like an aluminum flat, your black PS form, cut to size with a shear, drill route, or CNC. All of those are available in aluminum and so on. So basically the model will filter through that and pick up the right operations based on the material that you put in. As far as forming operations are concerned, we typically additional aerospace type forming operations from brake form, drop hammer, hydroform, cold jocko, all rolling, spin forming, all the kinds of things that you typically do in the sheet metal arena for sheet metal parts. Typically, if many times, the forming operation, after form operations are needed because of like in the case of stretching, you have to get the excess material that we use to stretch in the jaws of the stretcher. Also may have to put in holes after the forming process rather than putting them in the flat before the forming process. So even in check or using any type of extrusion, we can use parts maker or do forming operations. We forming operations in the extrusion, so then maybe a radius or whatever, but cut it to size or miter it, etc. In the arena, we picked typical finishing operations in the default templates, but the user can put in the type of finish operations that they desire or they typically use in the types of parts that they have. And the sheet model, it really works well with templates that we made for part types, etc. And we cover the range of painting, alidine, anodize, plate, chem mill, passivate, etc. Ruling is zinc, chrome, even metal bond bonding prep if you're going to do a metallic bonding operation. At least if you do have drape forming or want to platen form composites, all you need to do is to pick up the material, in this case from CAD, and we can then form the parts in the type of former that's selected. We'll have those two as two work options. All right. I don't have anything else as far as that. I just wanted to give you an introduction to the two models that are the process models that will be used within CATIA. Now we'll switch over to Chris, and he'll give you a demonstration of the CATIA model.
For that introduction. That's helpful to understand all of the sheet metal processes within here for manufacturing. So what I want to do now is show how we interface all of those processes to V5. Before I go into some of the details, I want to sort of go through a case scenario where the whole process, how it streamlines the fabrication estimation process. Indulge for a moment. We have a cost engineer is asking the design engineer, "Hey, help me out. I need a new estimate for a new bracket that we're making." And then he gives the designer some instruction to use the new Sheet Metal Cost Estimator application, and he's telling him or her to use the clips and brackets environment with 5,000 and in titanium, and then to save that as an MFG file and know when it's ready so that he can pick up the estimate for this new bracket. So let's go. So now I have that information. The engineer within CATIA is working in his part. He starts up the Sheet Metal Cost Estimator, which owns SEER, loads the appropriate settings based on the part that we're modeling. So the suggestion was to use the clips and brackets environment, which is set up. The defaults for that environment: one titanium alloys, one titanium, and we want 5,000 estimate. The estimate in SEER for that clips and bracket. The results are sent back into CATIA, so the engineer now has kind of what the cost is. He or she can go and look at the estimate by showing SEER. So the operations that are preloaded, by environment settings, the form, and we had the conventional notch, punch, and break form, the pre-forming, laser cutting, and after forming. And to save the file and let the cost engineer know, hey, the part is now ready, the estimate is ready from SEER, so you can use it in your stream estimation process, add it into the assembly, and so on. How quick, how streamlined the process becomes when using the in CATIA. The sheet metal interface itself, going into more detail, it works with the aerospace sheet metal design interface and or generative sheet metal design workbench. The parts contain what they call a web or a wall feature that determines that we're working in what's called the sheet metal type module in CATIA. When you're working in that environment, you can flatten the part and fold part to see the start, shape, and so on. So we created interfaces to all sheet metal operations within SEER-MFG that I mentioned to you, and there's much more because we include tooling, drilling, and all the detailed finishing operations. CATIA interface uses the sheet metal features such as flanges, bends, joggles, stamps, the thickness, the cutout perimeters and outer part perimeters and so on, and uses them within the cost estimate. So to start, you're going to open up your CAD file. So I'll open different. Then Sheet Metal Cost Estimator interface. This one has a wall feature instead of the web. The next we would do the certain quantities of the features for that design. They set up the shape complexity, initial shape complexity value. So in this case, we bring a nominal plus shape complexity, but you can override that view to based on your own experience. Then to select the manufacturing environment that matches the sheet metal fabrication circumstances. It can be part-based, operation-based, location-based, to basically to match that part. As Joe mentioned, you can set these templates up to part specific or other specific. So just select the turret press. The default types that are listed for the environment. These are predefined, but we can add them and the other form types that are available in the list. But generally, you might set these up so they're already predefined for the particular environment that you've chosen. But if you want to override that, you can do that. The form, the type, it changes the available form types as well as the press options for forming, after forming, part finish operations. So we're in quantity. Once you've decided you're ready to go, you'd click estimate. Just look at some of the available options. All of these options are available to choose and turn on or off to include or exclude from the estimate. Just click go ahead because we've built estimate, which is in the environment, enter the quantity, select material, and we now have our initial estimate. So go in and have a look at that. So in case we had we have quantity from SEER, sensitizations based on the rule environment file, the overall part size, the material, the options, in this case CNC turret press, and the shape complexity are all predefined. Some sheet metal elements to this in the detail part finishing. We had subsea prime and paint, so you can mix and match the elements of the different processes within SEER, and based on the choice you make for the environment and options. There's in the estimate that you can view. This estimate essentially is ready to introduce into your estimate process and refine it. Modify the estimate, trade studies, so then how that might look. So move that example, and I'll do select this part with a progressive die. Environment, we're using all the other settings, except now we've just changed the form type, changes the process options available that is according to the options that are turned on in the estimate, the element file, and then click estimate. So this is a trade. So in this case, it's reduced the cost a little bit from the previous estimate of turret press We could now go and have a look at that, how that looks. So slightly different setup. We now have finishing operations, this finish model, and we have the forming for progress dies. And itself, the results and inputs of the estimate are saved as what we call parameters. So information is stored into the feed of CATIA. So we have a record of the estimate that we just ran, what kind of form operations, any process options that we use, and the results themselves are all stored in part feature tree. So we'll reset this file. If you had a previous estimate, you'll have this record and become the default setup for re-estimate a new part or estimate this part. So if the part's changed in size or shape, or you've added more features or less features, the estimate will be updated according to that new information. What I'll show you is the last thing I want to show you is you would set up an environment to set up a new type for use within the CATIA interface. So we have these environments. I'll go ahead and start one, copy one, and that. Scripts. Then scripts. Firstly, we open up the file, all the elements that we use in the sheet metal interface. And what you do is now going to set the environment settings be the same across all the different elements of forming and after forming, pre-forming, drilling, and so on, or the technique for each of the different types of operations. Here you would set up your labor calibration, productification, production, any other wraps and financial factors. All of the elements you would set up according to the environment you're working in. Each of the operations themselves, you can set up the typical scenario, what kind of function and process tooling capability you have for that environment as well. So you would then change these accordingly and save that. So we'll do that. Go into the editor where you set up the default operations you want to show for this environment and material. So with the elements, then we're at the material analogy one is for aluminium type material, and choose the drawer as our default form, and go along and choose how we want to turn on the preform, the afterform, and operations for that material type. So this sets up the default configuration, all of which you can change required. What you would then save the environment. We'll just do the rules file here. Essentially created our new ribs environment for use within CATIA. So next time we fire up our interface, choose another different pair, and then I'll restart the interface. Zeros with the interface. We choose our manufacturing environment. We now have a new ribs environment, the default for that environment. So I can enter my quantity, or where I can start my estimating process on that new environment. So it really does streamline the whole estimation process for directly from within CATIA. So I think with that I've pretty much covered all the main elements I wanted to show you with the interface. So if there are any questions at this point, we'll to those questions.
Thank you. Let's see. So if you have any questions, you can type them into the Q&A panel. But I also wanted to announce really quick while you're doing that, that if you want a copy of slides from today, you can email me to request those at katimko@galarath.com, and I put that in the chat as well, so you can see that. So our first question for you, how does the tool figure out the process for forming the parts within CATIA?
The tool doesn't figure that out. It's the way the environment is set up to define the processes that are used for that environment. The part itself can be made in many different ways with sheet metal. So a part can be conventionally formed with presses and notches and punches and dies, or it'd be a complex tool that's used to press the part in one press operation. And each company would have a very unique setup. Therefore, they would set up the environment that matches their conditions of how they make the parts. So we don't try to preempt that from the design itself.
I have a machining module.
A full comprehensive machining model, the high speed, roughing, turning, drilling, etc. Comprehensive. And we're actually now working on a machining interface with Dassault to have a similar kind of process for taking the machine feeds and surfaces, sending them over into SEER in a more direct fashion, again to streamline that whole machining estimation process. That meant the metal and the composites interfaces that we have, we'll be running those from at the assembly level too, so you're able to get a complete kind of composite sheet metal machining estimate from product assemblies.
Okay. How do you get the flat pattern for a stretched part like a leading edge of the wing?
The flat pattern is something is defined part within the environment, what we call a material utilization. So that's something that is on in the estimate through the environment file. But we add on a thing to the flat pattern design itself. For example, if I were to unfold this part, we haven't added any material onto it. So we use this as a flat pattern, and the material utilization for stretch forming, I think, is quite high. The default template, we have it set quite high to accommodate for the additional material you'd need for that process.
Okay. This question is, let's see, can your Sheet Metal Cost Estimator window or dialog, can the box be modified to have graphical inputs, and that way the images drive your forming process steps?
That's a good question. We haven't done that. That's a nice, would be a feature, I think, for the next release. The particular interface is on the release process. So I'm not sure to get that in before we make this official for the first release. Thank you for the suggestion.
do you license for the Sheet Metal Cost Estimator?
To run the interface, you would need a separate license to your SEER model.
Okay, have any other CATIA interfaces?
Yeah, I mentioned earlier that we have a apply cost estimator. This one's available right now. They're in production and being used. That is what we're about to release and developing the mission face as we speak. Well, as I'm speaking, but rhetorical.
Very good. Let's see. Can it be used with version 5, with the version 5, 32-bit, 64-bit, R19, R21, etc.?
You have from R18 through to 16. I think actually 2016 only has 64-bit, but all the previous years from R18 to 25 we have 32 and 64-bit. So yes, it's available for all of the configurations.
A beta version that's available for testing, and is there one for CATIA version 6?
We can beta version ready for testing, and we can announce that. So if you can send the code where you would to say that you would like to run this as a beta, and for V6 it's a longer term roadmap, but the more term is the machining interface. And then we have the main interfaces, and we may be then working towards the V6 interface.
Does Galerath have an overview of its collaboration with the on SEER? Information might be helpful for sharing with Boeing engineering and estimating decision makers. Do we have that?
We can put that together, a general, the partnership agreement we have and a roadmap. So if that information, send in the contact information so we can respond to that. But it's actually available.
Okay, great, thank you.
For sale. That question again, you didn't get that answered by Chris.
How much does it cost?
No, it wasn't clear about how the flat pattern dimension. Let me just try to answer that.
Oh, sorry.
Okay. The flat pattern part, as Chris showed you, right? But we understand that you're going to have to add material on both ends to stretch form it. So what we've done is added extra material by increasing the materialization, which gives us more. We're buying more material. We know we have to buy more material. Did we put in there that we added material to the ends of the part?
For just the surface stretch form, I think we just end up with a higher amount of
materialization.
Yeah. So
we also could make a rule. You certainly could make a rule that says anything you select stretch form, if your typical grip is a 6-inch or whatever, you add 6 inches to the length, or 12 inches, 6 inches on either side of the length, and you would have that considered in the estimate for handling, etc., as the cost of the material and materialization. It really should be in both, Chris. Right.
So that some, if there's a rule we can add additional material, it's something able to do.
Right.
Yeah.
Okay, question.
Okay. A question is then how much would this cost?
Oh, about $1 million. No, I don't know, actually. That's kind of our jurisdiction.
Anybody that's wanting to purchase the model, hold of our office, 310-414-3222. Ask for Brian Glosser, and he's Vice President of Marketing, and he'll direct you to the right marketing person, and they'll contact you and do all the sales information that you would require.
Any other questions coming through? But if you do have more questions, you can always email us at info@galrath.com. I'll be able to address those. And thank you for joining today, and thanks to Joe and Chris for their presentation. And we will hopefully see you next time. Thank you for joining us today.
Thank you. Bye.
Everyone.